Okay, probably time to do an example. An algebraic example anyway. Given f of x equals x squared minus 4 and x equals 2, if x is less than or equal to 2 and if x is greater than 2. So I'm going to do an algebraic example, and this kind of looks ugly. This really should probably be here, more in the middle of the brace bracket, but you know, it depends how worried about that type of thing you are. And then I'm going to ask a question. Determine if f of x is continuous at x equals 2. Okay, well, the first thing I would do is I would remind myself of the conditions of continuity. And hopefully now, that little equation means a lot more to you. You got a whole bunch of things that should be shooting off in your head when you see that equation. So the first thing I'm going to work on is my first condition. There's 3 conditions here. Condition I is I'm going to be looking to see if x approaching 2 of f of x exists. And I put a question mark because I'm not sure if it exists right now. I really don't know. And to find out if it exists, what's the definition of a right-sided or a two-sided limit existing? Is that if it exists on both the left and the right and they equal each other. So you have to go to charts. You have no choice. Well, actually, do I? Yeah, I do, because I can use the mega property on right-handed limits and left-handed limits. So I could do charts. Okay, so I could do this. And I could put in values that are less than 2, but getting closer to 2. And I could put in values that are greater than 2, but getting closer than 2. And I could up here know that I would use x squared minus 4, and I could over here use x minus 2. I certainly could do that. Or I could do this. And I could do this. And I can use the mega property because this is a polynomial, isn't it? So I can take a value and I can plug that in, and I notice I'm going to get 0. And I can take this value and I can plug it in, and I know it's going to get 0. So if I had done all this work, you know that that would have gone to 0 and that would have gone to 0. And be my guest, you can do that, but because of how I defined the mega property for you, I defined all of the properties of limits to be true, whether it was a left-handed limit, a right-handed limit, or a two-sided limit. Go back and read that note. I defined it for all of those. So if I have a left-handed limit, I can still use the mega property as long as it's a polynomial. And I plug in 2, and it'll give me this value. What does this mean? This means that the limit, as x approaches 2 from the left of f of x, is equal to 0, which is equal to the limit as x approaches 2 from the right of f of x, which means that this does exist. We're good to go. So if you're going to do this question for me, you have to show me that you have to tell me it exists, and then you got to give me a reason. And I don't care if this is your reason, if that's what you feel comfortable with, and I don't care because of the way I defined it for you, if these are your reasons. But bottom line, I need to see this somewhere, right? Because that's what makes that exist. That's your argument. Okay, the question is, can I draw it? I'm going to say no, because actually Yes. Okay, I'm going to say yes. You could draw it. Yes, you could. That's not really what they're asking for in these questions, but I would agree that you could examine it by drawing it, and I'm certainly going to have you draw things like this during the course, so I'm going to say yes. But from now on, I'm going to say algebraically at the end of all of these. And that'll force you to have to do it algebraically and then do the drawing later. But yes, it could be done by a drawing. Number 2. What has to happen? F of x needs to be defined at x equals 2. And is it? I look up here. Look, there's an equal sign. So yes, f of x is defined at x equals 2. I don't care what it is at the moment. I just care that it's actually defined. So the answer is yep. And you can say f of x equals x squared minus 4 when x equals less than or equal to 2. Or, I believe it's x. I don't think I have an a anywhere in here. The formula has an a. And it's the value that the x is approaching. Okay. So in this case, the a value is 2. Okay. So, or if you wanted to simplify this a little bit, you could actually give me the value and tell me f of 2 is equal to 2 squared minus 4 equal to 0. And that's another way of showing me that it is defined there. Either one of those is great. You don't need both. Either one. So far so good. We've got the first condition for continuity. We've got the second condition for continuity. Gee, I wonder if we're going to get the third condition for continuity. The limit as x approaches 2 of f of x is equal to 0. And we know that from here. We found it. And that is also equal to f of 2. So guess what? That means that we have continuity. So therefore, yes, f of x is continuous at x equals 2. So that's how you do that question. And the question's probably going to ask you to be able to sketch these at times. If you needed to sketch this, what you would do is you would draw your axes. You know that something's going on at 2. You know that both of them equal 0 at 2. This one is x squared minus 4. So that's really a parabola that looks like this. Oh, negative 4. So it's going to go like this, sorry. There's all sorts of ways to graph it, but this is one way that I would think of graphing it. And we're supposed to use this only for values that are less than or equal to 2. So only that much gets used. And then this is a line. This is x minus 2. And it comes up, and it's going to look something like this, I think. So this is a rough sketch of what you've got. You've got the quadratic version, and you've got the line. Now, if you don't like graphing it that way, that's fine. Do a table of values for your quadratic and plot some points. Do a table of values for your line, and off you go. But you know what I did here, right? I just used grade 10 math. This is x squared minus 4, so it has a vertex of 0, negative 4. And this was x minus 2, so grade 9 math. This crosses through 0, negative 2, and it has a slope of 1. So over 1, up 1, over 1, up 1. And that's what I did to get there. So that's your graph. And you can see that you're continuous. Yay! Stop the video there, and I'll do another example.